Okay, so what we're going to try to do right now is prove that triangle ABC is similar to triangle ADE, which we've seen a diagram like this before. This is the A-frame problem, where we have this line parallel to this line. So remember, in these situations, first off, angle A is in both triangles, so angle A has to be congruent to itself. Also, as long as we have parallel lines, that means the corresponding angles have to be congruent to each other. So right there is angle, but don't forget there's actually two pairs of corresponding angles. And right there, so we know that all three angles of this little triangle right here are congruent to all three angles of this big triangle right here. So, boom, and triangle ABC is similar to triangle ADE. Now, the fact that those two triangles are similar makes it easier to find some side lengths. So what we're going to do here is we're going to find some side lengths in this diagram. Now first off, let's just label some stuff that we're given. We're given that AB is 8, BD, just this little piece, is 4, AC is 10, and BC is 6. So my strong suggestion to you, because otherwise you'll get confused and make horrible mistakes, is to draw each triangle separately. So here's what we're going to do. I'm going to take a little triangle. Oh my god, it's horrible looking, but it's okay. We'll just move on. Triangle ABC. And then the big one, triangle ADE. That one looks better. I feel better about that. And now let's label some sides. So we already have all three sides of this triangle, actually. We have 6 down here, 8 right here, and 10 right here, which means that it's a right triangle, but whatever, let's move on. And then, if we're looking at this, to find AD right here, we don't have AD, but we have AB and BD. So if we add 8 plus 4, that'll give us this whole length AD. So right there, that is 12. Now, this becomes crucial because what we have here, we have 12 and 8 correspond to each other because these are similar triangles. And what we can do, we can figure out the scale factor. So 12 divided by 8, which is, of course, 3/2 or 1.5. And then going the other way, you get 8 divided by 12, which is 2/3. So those are the two scale factors. Going this way is times 1.5 or 3/2. And going this way is times 2/3. So, what do we have to find? We have to find DE right here, DE. So, DE, all we have to do, we take 6 BC, which corresponds to DE, and we do 6 times 3/2, because that's the scale factor, and DE should be 9. Perfect. All right, now we need to find CE. This little piece right here. Seems weird, right? Kind of hard to find. It's okay, though. We can do this. Because if we find this whole thing, AE, this whole distance, then we can just subtract this 10 and figure out the rest of it. So, here's what we did. So we got 10 times 3/2, which will give you this whole distance, 15. So if we look back at the original diagram, this whole thing is 15. And if this piece is already 10, well, this piece right here, all that's left for it is 15 minus 10, or 5. So there you go. That's how you would solve a problem like this. First, just make sure you draw the two triangles separately, because it makes everything a lot easier to figure out the sides and figure out what corresponds with what, too.